So hello guys, my name is Anirudh Menon. I am a third year medical student. So in this video, we will look into a very simple yet very conceptual topic of physics, that is one-dimensional motion. So I don't believe in discussing a lot of things and spending so much of hours and hours of teaching where we derive all the equations of motion. Nothing is required of that kind. As far as our exams are concerned, we will have to solve a lot of questions to understand this chapter. So I thought of making videos where we will be solving the question to understand the concept. So that is much better so far as this kind of a topic is dealt, if this kind of a topic is concerned. So yes, I have selected certain questions. We will be covering those questions, wide variety of questions in a few videos, and with that we will be coming to such a good exposure to this topic so that it becomes more and more easy for whoever is watching this video. So this question, which is question number 1, is actually a very simple question which is from the topic of one-dimensional motion, and many a times these kind of questions have been repeatedly asked in the Neet exam. So they are saying that a particle moves in the xy plane according to the equation x is equal to this much and y is equal to this much. So yeah, you are actually representing the motion from two axes, right? So they are asking you the acceleration of the particle. So don't get scared by seeing x and y equation. Just try to differentiate this and find the velocity and acceleration on both axes. Then we will decide what to do after that. So what is the velocity along x direction? Velocity along x direction is dx by dt. So if you differentiate this with respect to time, you will get 8t plus 5. And here velocity along y direction is equal to dy by dt, and this is equal to 5. Right? Now acceleration along x direction is dv by dt. You are differentiating this expression with respect to time, and therefore you will get this as 8 meter per second square, while acceleration along y direction is 0, because you know differentiation of a constant is equal to 0. Therefore, I can say that only along x direction is this particle is having an acceleration. Along y direction, since acceleration is equal to 0, the velocity along y direction is a uniform motion, or you can say that it is a constant velocity, so the motion is a uniform motion. Right, along x direction it is uniformly accelerated motion. So the acceleration along x direction is, answer is option number 1, right? 8 meter per second square. So this is a fairly easy question which all of us will be solving. Now let's proceed to the next question that I have selected. This is the next question that we have. The displacement of a body from the reference point is given by root of x is equal to 2t minus t. So 2t minus 3. So this x is a function of time, right? Where x is in meters, time is in seconds. This shows the body is, right? We need to choose from these options. Do you find a catch here? We'll try to solve this in the best way possible. So x is equal to 2t minus 3 the whole square. Now open it like a minus b the whole square. So this is 4t square minus of 2 into 2t multiplied by 3 plus 9, right? So this is equal to 4t square minus 2 2's are 4, 3's are 12t plus 9, isn't it? So this is equal to x. Now the point is, see, as per the options, you are asked to find out something, or you are supposed to comment on the acceleration. We are supposed to comment on the velocity to understand this. We have to comment on the acceleration and velocity to conclude from the 4 options. Let's find out the velocity here. Differentiate this with respect to time. 4 2's are 8t minus of 12 and 9, it is a constant, so yes, it's 0. And acceleration is equal to how much? This will be 8, right? So the point is that here velocity is 8t minus 12. Now the question is the velocity 0 at any point of its motion? Is the velocity 0 at any point of motion? Let's put this equal to 0 and check out whether it is becoming 0 during some positive value of time t. I can say that if this is equal to 0, this implies, how much will this be? I can take around 4 outside, isn't it? 4 multiplied by 2t minus of 3 is equal to 0. Now 4 cannot be equal to 0. 4 is not equal to 0. Therefore, I can write 2t minus 3 is equal to 0. Therefore, t is equal to 3 by 2. That means as time passes, It is actually starting when time is t is equal to 0 seconds. Now as time increases, when time is equal to 1.5 seconds, its velocity is 0. Its velocity is 0. So what does that imply from this? What do you understand from this? This is very much interesting because it is actually having some kind of velocity, but it is decreasing and it is becoming 0, right? And then again it is going to be more. So at time t equal to 3/2 seconds, it is at rest. Therefore, clearly I can understand that it is at rest at time t equal to 3/2 because velocity at time t equal to 3/2 is equal to 0. So the answer for this question is option number 2. Now in the third question, they demand a knowledge of the very important equation that we are supposed to learn, because for some years they haven't asked the question like this in the NEET exam. But let's be equipped with every kind of equations that we are supposed to know here. See, they are asking you a particle about a part to find out something like tth second and t plus 1 second. So do you remember this? Distance traveled in the tth second. Distance traveled in the tth second, I can write it as st is equal to u plus a multiplied by t minus half. You might have learned this in a different format, u plus half a into 2t minus 1. But I prefer to remember it in this way because it is more easier to remember it in this way. For me, personally speaking, I like this equation in this particular format. U plus a, t minus half. U plus a into t minus half. Rather than saying it as u plus half a into 2t minus 1. U plus a into t minus half. That's it. Now what are they asking here? If the sum of the distance traveled in tth second and t plus 1 second is 100 centimeter, then velocity after tth second is. So they are asking you to find out the velocity after t second. Okay. What do we get from this? I can just add the sum here, sum of the distance in tth second. So what is the distance traveled in tth second? U plus a into t minus half plus of u plus a into t plus 1 minus half. Okay, so this is the sum of the distance traveled in tth second plus t plus 1 second. So this is equal to u plus a t minus half plus u plus a t plus half. Right, so this is equal to 2u plus at minus half plus at plus half. So this is equal to a into t plus t, or I can write it as 2t. Yes, that plus half and minus half will get cancelled off. So this is equal to 2 multiplied by u plus at. Okay, now this is given to be how much? 100 centimeter. Right, so what is u plus at then? U plus at is equal to 50 centimeter. Now what do you understand from this? What do you understand from this? Distance, I mean velocity after t seconds. Velocity after t seconds of a body. Now tell me the answer for this. Velocity after t seconds of a body whose initial velocity is u and acceleration is a. Acceleration is a, initial velocity is u. I am asking you the velocity after t seconds, provided this body is having a uniform motion. So uniformly accelerated motion. So this is v is equal to u plus at. What is this? It has an initial velocity u, acceleration a, constant acceleration a, and after time t is equal to t seconds, the velocity is equal to v. And what is this here? U plus at. That means this is equal to the velocity after t seconds. So this is my velocity and this is my answer. So my answer for this question is option number 3. Simply by going by the language of question, I just had to add these two things to find the answer. Nothing more was required from my side. So I just went by this particular method, but I accidentally, or interestingly, I landed up in the answer. So this is something that I like about this question. So let's go to the next question now. So friends, this is a very commonly asked question and very popular question, and for this I will tell you a trick to solve this, and you can simply remember that formula. A particle is thrown up from the ground with a velocity 20 meter per second, and simultaneously, see, this is an important sentence, important word, simultaneously a similar particle is dropped from a height 100 meter above the ground in the same path of the former particle. So that means I have a ground over here like this, and I'm throwing this particular particle up with a velocity of 20 meter per second, right? And at the same time, simultaneously in the same path, I'm just dropping another particle down. That means the initial velocity is equal to 0, right? And they are asking you the time of collision. So whenever you get a question like this, remember time of collision is equal to what? This is important. Initial separation divided by initial relative velocity. Right? So this is time of collision. Time of collision is equal to initial separation divided by initial relative velocity. Remember this. This is a very important, straightforward kind of a formula that you can remember, and you can simply use this to solve this question. It's a very easy question now. Just put in this particular question now. Initial separation between these two particles, it is 100 meter. So 100 divided by initial relative velocity. So that means they are coming in the opposite direction. Okay, so you'll have to add the velocities, but here the second body is dropped from that height. So that means initial velocity is equal to 0. So the relative velocity is this plus this 20. So that's just 20. If you divide this, I will get it as 5 seconds. So at 5 seconds, these two particles will collide, provided the distance between these two is 100 meter, which is as it is given in the question. So remember this particular equation. Time of collision is equal to initial separation by initial relative velocity. Now let us modify the situation, and I have got a very beautiful question over here, and let's understand how to solve this question. See this question now. Two particles at a distance 5 meter apart are thrown towards each other on an inclined smooth plane with same speed v. So let us suppose my first body is over here. So this is my first body and this is my second body. Okay, and the distance between both these things is 5 meters. So the distance between both these things is 5 meters. So the gap between these two is 5 meter, and both of them are thrown with the same speed v. So this is thrown with the speed v. This is also thrown with the speed v. It is known that both particles are moving on a straight line. So the straight line is on the inclined plane. So this is an inclined plane. So it is moving along the straight line. This is moving in a straight line. This is moving also in a straight line. You can use the concept of straight line motion over here. So that is what they are meaning by saying that it is known that both are moving in a straight line. Now, find the value of v. Okay, we are supposed to find this. We are supposed to find this. Okay. If they collide at a point, so this is the catch over here. If you can understand this, then it is more of an easy question. If they collide at a point from where the lower particle was thrown, lower particle was thrown from this, the upper particle was thrown like this, but they are not colliding over here in way between. No, it is said that even though the particle is thrown from this, the lower particle is thrown upwards, both of them are colliding at this point only. But in the image, I am seeing that both of them are thrown in the opposite direction, but they are not colliding in the a path in between within this particular 5 meter. No, they are not colliding over there. They are colliding at this point. So that means the lower particle went up somewhere like this, then it came back like this, and it reached to its initial position. When the lower particle went up like this and it came back in this way, and when it reached its initial position, the upper particle comes down and hits the lower particle. So the lower particle completed its entire motion, and then when it completed its entire motion, the upper particle is colliding it. That is why they are saying that both of them are colliding at the initial point, at the initial position of the lower particle. So the lower particle went all the way up, it came down all the way down, and when it reached over here, the upper particle also reached over here, and they are colliding here. So what is the time of collision in this question? Time of collision in this question is the time taken by the lower particle to go up and come down. Lower particle to go up and come down. Is it? Yes, it is. So the time of collision is the time taken by the lower particle to come down, and when it reached over here, then the upper particle is coming and colliding with this. So this is the catch in this question. If you can crack this, then there is nothing difficult in this question. See, motion on an incline is very similar to free fall. See, This is only influence under the influence of gravity it is moving. But in a normal free fall condition, you will take the acceleration due to gravity as g, right? If you throw a body upwards, what is the acceleration on it? The earth is pulling it. What is the acceleration? G is the acceleration. But in this condition, you cannot use entire g, right? If this is mg and this angle is theta, then this is mg sine theta and this will be somewhat mg cos theta. I mean, this is not mg cos theta. Mg cos theta will be somewhat like this, right? So this is how the value will look like. Now I can just remove m over here. So I am just considering acceleration now. Acceleration to gravity is g sine theta. This is the net g. This is g cos theta. So this angle is also theta, right? Okay. Now this is the concept that you are supposed to remember. So this can be proven geometrically, but remember this. This is something that we are supposed to remember also. So this is equal to a normal free fall provided you are taking g as g sine theta, right? This is the only catch over here. You can take this as g sine theta. In normal free fall, if you are taking g, here you have to take it as g sine theta. There is nothing more complicated in this. Now, what is the time of collision? The time taken by the lower body to go up and come down. Time taken by the lower body to go up and come down is t is equal to 2 v by g. Now here g sine theta. Isn't it? You use this equation like you throw up a ball from below and you are asking yourself like what is time taken by the body to reach upwards. Time taken by the body to reach up is equal to u by g. U is the initial velocity with which you are throwing it, u by g, and that same time it takes to come down. So this is u by g. U by g plus u by g is 2u by g. But here it is very much equivalent to saying that this is a free fall provided you are taking the g as g sine theta. So here theta is given to be 30 degrees, isn't it? So this is 4v. G sine 30. Sine 30 is 1 by 2. G by 2 that goes upstairs, and this is 4v by g. Okay, 4v by g is my time of collision. Now what is time of collision? Time of collision is equal to initial separation. How much is the initial separation? 5 meter divided by initial relative velocity. Relative velocity in the initial position. So initial relative velocity is both are in the opposite direction, add them. V plus v is 2v. So this implies 5g is g, you can take it as 10 meter per second square. So this is 50 is equal to 4 2s are 8 v square. So this implies v square is equal to 50 divided by 8. So this is 25 into 2. I can write in this way. Now 8, this is 4 into 2. I can cancel this off. Now what is v then? V is equal to 5 by 2. So this is equal to 2.5 meter per second. So this is a modification of the previous normal condition, but this is a slightly good question. Remember this question. I like this question a lot. So I thought of discussing this question with you. Okay, this is a small catch point in this question. This is a normal free fall condition and you are supposed to remember, provided you take g as g sine theta, provided you get the concept when you are given such a question, then you will be solving this. Okay, so let's go to the next question now. So this is an exactly similar question with the previous one which we have done a little earlier. Let's go through this and solve this once more. So yes, I have a mass A is released from the top of a smooth inclined plane. So let me consider this angle as theta, right? So this is my mass A. This is my mass A. It is released. So your initial velocity is equal to 0. Okay. And it reaches the bottom in 3 seconds. So with 3 seconds, it reaches the bottom. At the same instant when A is released, a second mass B is projected up along the plane from the bottom. So here is my mass B. And this is projected with a velocity v. Let us suppose we don't know the velocity, so let's suppose it is v. And with this v velocity, a person is projecting it upwards along the direction of the plane, right? The b travels up the plane, so they have mentioned what is happening very clearly, not like the previous question. There they were asking us to analyze, but here they have said what is happening. It goes up the plane like this. It stops here where the velocity is equal to 0. It comes back, and when it reaches here, A also is also reaching over here. You got it? It goes up, here the velocity is 0, then it comes back, and when it reached the bottommost point, A has also reached the bottommost point simultaneously when the B has reached the bottommost point, right? So it reaches the bottom simultaneously with A, not colliding with A till it reached the bottom. So it went all the way up, it came all the way down, but it did not collide with A till it reached the bottom. Okay, so both of them are simultaneously reaching the bottom without any collision. Then we are supposed to comment on this. Now, tell me what is the time taken for B to come back here. You are throwing a ball up, it goes all the way up, it stops at a height, some height, it stops where the velocity is 0. So the time taken or time of ascent, time taken for it to reach the topmost point is u by g, and while it comes down again it is u by g. So total time taken for a ball thrown up, free fall, ball thrown up, it went all the way up, it came all the way down, that total time is equal to 2v by g, right? But here gravity is acting in this direction, this component of gravity acting in this direction is g sine theta, where theta is the angle of the inclination of the plane. Okay, I mean angle of inclination of this particular inclined plane. Now see, A is taking 3 seconds to reach here. Now that is the same time taken by B to reach all the way down. So this is equal to 3. Fine. So this is my first equation. Okay. Another thing that I can do is that see, both of them are colliding at the bottommost point. Both of them are reaching simultaneously at the bottommost point. So time of collision is 3 seconds. Okay, this is equal to initial separation, which is 18, divided by initial relative velocity. So what is initial relative velocity here? V is equal to 0, U is equal to 0, but here U is equal to V. So the net is V itself, initial relative velocity. So therefore I can say V is equal to 6 meter per second, right? So initial velocity of B is 6 meter per second. So right away I am getting this option to be correct. So this is a correct statement in this particular question, right? So this is the initial velocity of B. Another important thing to remember here is that if I get V as 6 meter per second, I can straight away plug this in over here. So this is 12 is equal to 3g sine theta. So from here I get g sine theta is equal to 4. Okay, so I got g sine theta as 4. Now we are asked to find out the final velocity of A. Final velocity of A. So it is moving all the way down, gravity acting as g sine theta. So I can use V square is equal to U square plus 2AS. So from here V square is equal to V means the final velocity of A when it reached down is equal to U square is 0, 2 multiplied by g sine theta is 4 multiplied by distance is 18. I hope this is seen over here. So V square is equal to 2 multiplied by 4 multiplied by 18. So I can write this as 2 into 4 into 2 into 9, right? So this is V is equal to, from this 2 and this 2 I can take a 2 outside, 4 root of 4 is 2 and 9 root of 9 is 3. So this is 3 2s are 6 2s are 12 meter per second. But here they are saying it as 18. This is also wrong statement. Now displacement of A is equal to displacement of B. Is it correct? No. As per what is happening to A is coming all the way down. So displacement of A is 18 meters. There is no doubt in that. It is a straight line motion. There is no confusion in that. It comes all the way down. So the displacement of A is 18 meter. But displacement of B is 0. It comes all the way up. It comes to the same initial point. So the net distance displacement traveled by it is equal to 0 because initial position and final position are same. So displacement of A is not equal to displacement of B. Displacement of A is 18 meter, displacement of B is 0 meter. Relative velocity between them is 0 only at the final position. See, at final position what is happening? At the final position, velocity of A is 6 meter per second while velocity of B is 12 meter per second, while their directions are equal. Directions are equal but the magnitudes are not the same. Magnitudes are different. Direction is equal. Both are coming down. So how can the relative velocity between them is 0? If the magnitude is it's not matching, then their relative velocity is not 0 at the final position. So for this question, my answer will be option number 1. So with these two questions, I hope you have understood the way to solve a question whenever they ask you two bodies are thrown simultaneously. What is the time of collision? When do they meet? When do they reach the same position? Time of collision means that they are meeting in the same one position. So they are covering equal I mean, they reach the same position in that particular time. So this is the basic idea so far as our question is concerned. So I have solved 3 questions of this kind. One was a very basic question, then we have modified it to get these 2 questions. Okay. So with that, we come to the end of this particular first video. In the next subsequent videos, we will look into more and more concepts of this particular chapter. We will solve more variety of questions in this chapter. So yes, stay tuned and keep supporting this channel. Please like, share and subscribe to my channel. Thank you.